Hello everybody, in this screencast I'm going to use Cocos2d-x version 3.0 Alpha 1 to demonstrate gravity and touch responsiveness. So I'm going to start from scratch. Let me find my Cocos2d folder. And I want to go to the Tools folder and the Project Creator. And I want to run and create project. So I'm going to create a new project called Gravity Demo with the package name edu.fullsail.ngms.emto, language C++. So those have been created. So I want to go back and to the projects directory, and there's my new project Gravity Demo. So we'll open up Xcode 5. Open the iOS Mac project and the Xcode project. And I always want to change the build target to iOS. Pick an iOS simulator and click the play button just to make sure it works. It does work, so I'll quit that. Let's open up hello world scene.h. So I need to include Box2d. Box2d is going to handle the physics for us, and it's in a folder called Box2d. And I want the file called Box2d.h. I also want to use the namespace Cocos2d, so I'm going to type using namespace Cocos2d. And that's actually already in the C++ file right here on line 3, but I need to reference those class names in the header file, so I'm going to just delete this and use this line using namespace Cocos2d in the header file. So I want to put a preprocessor directive in there. Define the pixel to meter ratio as 32, and one macro. Define world to screen as a function that takes a number n and returns that number n times the pixel to meter ratio. So this will let me think about everything in terms of meters instead of pixels. It'll convert 1 meter to 32 pixels. Also want to declare a few functions. We'll go down here after this selector callback. I'm going to want a tick function that does not return anything. It takes a delta time as an argument. I want a function called create star. So this is just going to make a star on the screen, and that's what will have the gravity. And I want to make a function called touch began that returns a boolean and takes 2 arguments, a pointer to a touch object and a pointer to an event object. And the touch object and event object are why I needed to use the Cocos2d namespace. Okay, so let's go to the C++ file. And at the top, I want to declare a couple of global variables. One is a pointer to the Cocos2d world. And one is a Cocos2d vector called gravity. So at about line 58 to 74 is where it makes the hello world label and background image that you see in the default project. So I'm going to delete all of that. And I want to set up my gravity vector first. So gravity.set, I want it to be 0 in the x direction and negative 9.8 meters per second in the y. So I'm just going to write negative. I'm going to use my macro world to screen and put 9.8 inside the function. I want to declare a variable called doSleep. It's a Boolean, and it will allow sprites to not be redrawn if nothing is interacting with them in the physics simulation at the moment. So that'll save cycles and let things animate faster. So I'll set that to true, and I'll use that in just a second. I'm going to create my world to be a new v2 world with gravity, the gravity vector as the only argument. And then with this new world I created, which is a pointer, so I'm going to use the arrow and call the setAllowSleeping method and give it my doSleep variable. So the world is all set up. Let's get the touch listener set up. So it's an auto release object, so I'm going to type auto and I want to call it touch listener. And I want to use the event listener touch 1x1 method, well, class actually, and use the static create method in that class. So now I have a touch listener. I want to tell it what to do. So touch listener, and I want to use the onTouchBegan method and set it equal to a Cocos callback. So Cocos callback. The number 0, 1, 2, or 3 is how many arguments the first function uses. So I'm going to use callback 2. And the function I would like to be called is hello world touch began, which is my method that I'll make in just a second. And the target where the function can be found is this. So now I have a touch listener. I need to assign that to the event dispatcher so it'll know to send messages to it. So I'm going to use the get event dispatcher method and call the add event listener with fixed priority method, and I'll give it the touch listener I just made, and for the fixed priority I'll just put 100 because there's only one. It won't matter now. I also need to schedule the tick method. This is going to be the game loop, so I'm going to call the schedule method, and it needs a selector. So I can get a selector by calling the schedule selector function, and as the selector I'll pass in my method hello world tick. So let's create the touch began method. Touch began method will return a Boolean. Namespace is hello world. The method name is touch began, and it takes two arguments, touch star and event star. So in this function, you put everything you want to happen when the touches began. For this example, all I want to do is call one function, the create star function. So hello world, create star. And I want to give it the point to create the star at. So I'm going to use the touch parameter that I was given and use get location, and that'll give me the point where the touch is. So let's create a star for this project. I'm going to open up Illustrator. Let's make 50 by 50, call it star. It's the star tool. It's fine, and file, save for web. And let me find my project. So alpha 1, projects, gravity demo, and I'll just put it right there. Also want to save the Illustrator file, so save as star.ai. Okay. So over here in the blanks area, right click and add files to gravity demo, and I will just find that file that I just made, ping file. Let's create the create star method. So void hello world create star with the point P. So I want to make a sprite, so auto, I'll call it star sprite, and I'll use the class sprite and the class method called create with the argument star.png. And now I have a star sprite. I can set its position to the position that I was passed, P, and then I can add it to the scene. So this add child, actually there's more than one option. I'm going to use the second option where you pass the child node, which is the star sprite, and the Z order, which is 0. So that's enough to get it on the screen. So here's where I'm going to add the physics, but what I have so far should be enough to just create the star sprites on the screen when you click on it. So I just want to test that. Okay, it says linker error. I referenced a method called tick, but it's not showing up anywhere. So let me just create that method tick. Let's see if it'll run now. There it is, and I can click and create sprites on the screen. That's great. Okay, let me add some physics here. So the first thing I need to create is the B2 body definition, and I'll call it the star body def. So with my star body def, it's not a pointer as you see, so I'm going to use dots to access the properties. Things like type is a B2 dynamic body, so it'll react to physics. And I can set the position. The position I want to be a vector 2. And I basically want to put it exactly where the star sprite is, so I'm going to use star sprite get position X and star sprite get position Y. And with my star body def, I can set the user data, and that's going to be the sprite itself, star sprite. Now that I have a definition of a body, I want to actually create the body itself. So it's an auto-release object called star body. And I'm going to ask the world to use its create body method, and I'll pass it a reference to the star body def that I just made. And now I want to create a fixture which will attach the body to the physics simulation. So this star is pretty much in the shape of a circle, so I'm going to use a circle shape. I'm going to call it circle, and then I'm going to set the radius of the circle to be, I'm going to use my macro world to screen and set it equal to about 0.6 meters. So now I'm going to create my fixture definition. B2 fixture def. And I'm going to call it star fixture def. And now with my star fixture def, I can set properties like shape. It's going to be a reference to the circle I just made. And I can set the density to be about 1.0. And I can set the friction to be about 0.6 F. You can play with all these numbers, of course. Star fixture def dot restitution is the bounciness level, and I'll set it to be 0.8. So now I've got the fixture definition. I want to create the actual fixture, so I'm going to use the star body and call the create fixture method and pass it a reference to the star fixture definition that I just made. So that's fine. The physics part of it should be created now when I create the star, but we have to actually tell the program during the game loop called tick to update the position of the image on the screen. So the physics simulation in the background will be changing the position of the objects when it comes to their physical bodies, but it's not going to attach itself to the actual image, the ping image that we made in Illustrator on the screen. We have to do that manually. So this is what's going to happen in the tick method. I'm going to set up a couple of variables, one called velocity iterations and one called position iterations. And this is just how many iterations the physics simulation is going to do in the background on every pass through the game loop. So of course, the higher the number is, the more accurate it'll be and the slower it's going to be. So I'm going to ask the world to go through one step of its physics simulation, pass it the delta time and the velocity iterations and the position iterations. So I'm going to go through a loop that gets every body in the world. Each one is an auto-release object. So I'm gonna say B, get body list, and that'll just return the first body. And then to see if we should keep going through the loop, it's gonna just check to see if B is not null. And then the next step in the process would be that B should be assigned the next body. So I'm going to use the method called getNext. So inside this loop, first thing I want to do is check to make sure that the body I have has a sprite attached to it. So I'm going to get its user data, which should be the sprite, and just make sure that that is not null. So now that I know that that will not be null, I can grab that sprite. I'm going to call it my actor, and I need to cast it to a sprite because I know it's a sprite, and get the user data. So now I have the sprite back I can work with. So I can do things like set its position and rotation. So my actor set position, and I just want to set the position to be the same as the position of the physics body B. So I'm going to use body get position dot x, and the body B get position dot y. Also want to set the rotation to be correct, so my actor is going to set rotation to be -1 times Cocos defined macro called cc radians to degrees, and the angle is the angle of the physics body, so B get angle. So the position and rotation have been updated. Another thing I would like to do is I would like to remove the sprite and the physics body if it goes off the screen. So I just need an if statement, and I want to do this after I've updated the position. I want to get the position y and say if the position is less than, let's not say 0, because if we say 0, the sprite's going to disappear when it's halfway off the screen and it's going to look strange. Let's wait till it gets a full meter off the screen. So I'll say less than 1 world to screen, sorry, negative world to screen 1, so 1 meter. So if it's less than -1 on the y-axis, or what if it goes off the left side of the screen? Or what if it goes off the right side of the screen? If it goes off the top, I don't care, it'll just fall back down. In this case, I want to get the right side of the screen, so I want to call the director, get an instance of him, ask him to get the visible size of the screen and the width property, and then that would put me right on the right edge. To that I'm just going to add 1 meter. So it'll go just off the right side of the screen and then disappear. So if any of those conditions are true, I want to remove the child called my actor, and that'll take the sprite that you can see off the screen, and from the world I want to destroy the body called B, and that'll take care of the physics body behind the scenes. So let's run this program and see what happens. So sprites are added and they fall under gravity. They bounce into each other. So there's physics and gravity. So if you wanted to add a floor At the bottom, you can see them bouncing on the floor. And when you add that floor, you would just want to make the type a B2 static body instead of a dynamic body. So dynamic bodies will respond to gravity, static bodies will not, but they will still, you can still bounce things into them. So thanks for watching my tutorial. If you have any other ideas for tutorials you want to see, just send me an email. Thanks, bye.